Hi everyone, and welcome back. So I didn't quite get to say it in the last video, but cos theta is the x value, cut out just right at the end there. Anyway, timed it almost perfectly, almost. Now, we're moving on. So we want to have a look at how we can actually use the unit circle to evaluate some of our sine and cosine tangent functions. So you might remember from the first video that we measure angles in radians, and we always measure from the positive direction of the x-axis. So we start off here at 0 degrees, or 0 radians I should say. Then we had pi over this side, and once we go through a full revolution, it's 2 pi radians. And we have up here, this is just half pi, and we wrote that as pi on 2. And then down here we had 3 pi on 2. So these are the key angles that we need to know to be able to evaluate these kinds of problems. The first one is asking us to evaluate sine of pi on 2. So first off, when I'm looking at this, I'm saying, okay, so this is asking us about sine, and we know that sine relates to the y value. So I want to know what the y value is when the angle is pi on 2. Starting from here at 0, I'm going to turn through the angle until I reach pi on 2, which this is the line here that goes up to pi on 2. Okay, so I'm looking at the y value of this point right here. And because of the unit circle, we know that that has a y value of 1. Done. So the next one, cos of 3 pi on 2. So cos is asking us for the x value when we've gone through an angle of 3 pi on 2. That's 3/4 of the way around the circle. So I'm going to turn through, there's pi on 2, pi, and then 3 pi on 2 takes us down to here. And the point on the circle is this one right here. So I want to know what the x value is there. And, well, the x value, if we follow back up, would have a value of 0. So we can just again fill in that the value there, the cos value is 0. The next two are a little bit different, and I've chosen these two examples specifically to cover this skill. So in tan of negative pi on 2, now first off it's a negative angle, which is a little bit weird, you don't often see them. Also it's asking us for the tan function, so it's asking us what the y value is when it crosses that imaginary tangent line that runs along this right-hand side of the circle. Okay. So the thing is, if I go through tan of negative pi on 2, so starting here at 0, I would turn backwards through pi on 2, which would actually take me back to here. So again, we're looking at this same point on the circle, and if I want to know the tan value there, well, if I'm drawing the line, it's going to go straight down there. Straight down there. Okay, it's going directly down, and our tangent line also goes directly down. So because those two lines are parallel, they're never going to intersect, and because they're not intersecting, well, we end up having to say that the tan value there is undefined. Okay, that could also be proven using the fact that tan is sine over cos. We could put the sine value over the cos value, but you'd end up with something divided by 0, which would basically indicate that it's going to be undefined as well. And the last one is tan of 47 pi. Now 47 pi, you can imagine we have to do quite a few revolutions. So there's 2 pi, and then we go around again 4 pi, and again 6 pi, and we keep on going until we eventually get around to here. Okay, so this point out here is going to be where 47 pi is. That's an odd number of pi. And I want to know what the tan value is there. What I'm doing is I'm drawing a line from the middle of the circle to the outside here. And the problem is that when I'm drawing out that direction, it never actually crosses the tan line because the tan line is over on this right-hand side of the circle. But whenever we're going out that left-hand side, what we do is we just trace back along until we go and we cross the tan line, which would be crossing right here. Okay, and the tan value right there doesn't have any height, so the tan value is going to be 0. Alright, now the next thing to do is to have a bit of a look